Okay, we'll check today that script of Hive, which is HQL. First, we already know we are creating one table with same meta, same column name as customer dimension main. So I think I'll write in this separate file. In first stage, create customer dim temperature. Create customer dim temperature with schema of customer dim main. Customer dim main. Without any result, this table is created. Then we said second, take all the inactive result from stage number one based on this query. Step number two, result which are inactive or data, I should say, data which are inactive from main table. Okay, so this table I'll call as a main table. It's for simplicity, and this is a temporary table. Data which are inactive from main table based on two condition. First condition is if result is inactive, so active flag is equal to n, and based on two conditions, active flag n and uh, to effective date is not null. If we find these two things, we'll keep that data in customer dimension table. In third stage, we are comparing it. We said get all records which are going to expire, not yet expired, but going to expire. How do we know how many records are going to expire? This is the query. Insert into ETL data schema. This is FIU dot customer dimension temp. This is my temporary table. So we are writing in this table, and from which table? Where is from query? From line number 44, from this table, customer dimension main table. Okay, so this TGT is alias given for customer dimension main, and from customer dimension main, we are taking customer ID, customer alt ID, customer name, gender, load date, effective from date, and date underscore sub. So this is one function, date underscore sub. Current date, this will take your system date, comma 1. So this will subtract 1 day before. Like today, if I'm checking for 29 July, if I use date sub current date 1, this will take me to 28th July, yesterday date. That's what this thing is doing. As effective to date, n as active flag, from main table update date, we are joining this result with customer dimension is stage one. Now, this is stage one is having one directory location, and that is big data staging directory, stage one directory. Okay. So big data is stage one. Result which are new, like when we updated records in RDBMS, that result is only coming in this directory, and that alias name we gave as src. So in this line, we are joining with this table based on customer ID. So if both have a same customer ID and their active flag is Y, when they pass this two condition, then we are doing binary matching. This matching we call a binary. We are doing this based on hash functions. Okay. So in RDBMS also we have the same thing. Using hash functions, we can run this query. It compares between customer alt ID, customer name, gender, whether they are the same or different. If they are different, means the record is expired. If they are same, means record is not expired, right? If everything is same. So we are joining based on customer ID condition. If they found the record is active, why? Then we are giving one condition where and checking this value. You can check, you can copy this line and run separately in your cell. See the log file, what is happening. After step number 2, whatever result is expired, this is stored inside customer dimension temp table right here. Condition on main and staging table. So two conditions we have. First, we are joining it, that's an inner join. And second one is if their customer name, their customer alt ID, and their gender. If this three result is exactly same after joining also, then result is not yet changed. If this is changed with ID and their flag status, the result is changed. And that data we are writing, change or expired record is being written on temporary table. Temporary means the same customer dim temp table. Then in third stage, copy active records from main to temp table. Okay, so whatever records are active, how do we know which are active? Using status Y. And this is the condition we pass here. TGT alias name is customer dimension main. So from main table, we take again customer ID, alt ID, customer name, gender, date, from date, to date, active flag, which is Y, update date, from fiu.customer dim underscore main, where active flag is Y. So active flag is Y and not exist. Inside this, we give select one from fiu.customer dim stage one. Select one from means this will just give one result, like limit one src, where condition is equal to this. So result which are active, it will go to temporary table. Result which are inactive flag, like active flag is having n value, this will be there in customer dim main table itself. Then we are joining this result. We are using union. Now, what is a union? Suppose I have a is equal to 0, 1, 4 and 5, 7, 3, and b is equal to 2, 1, 2. If I say a union b, this is the sign of union. So result will randomly shuffle. I'll not get data in order. I may get data in order also, or maybe this B can come first and A can come later. So this result will be 0, 1, 4, and 5, 7, 3. You can consider this is my column 1, column 2, column 3, 2, 1, 2. So after joining, we will, after union, we will have this result. And in this union, we are using the Y condition again. How many results are active with the flag status Y? We compare this customer name alt ID from two tables, SRC table and DGT table. SRC is my customer dimension stage and main. Result which are active, it will be there itself. Results which are inactive and having flag status as N, they will go to customer dimension temporary table. So this is stage. Step number 2 and step number 3 is for CDC. Only capture the data which are changing. Data which are not changing, do not capture them. Then in fourth step, copy only updated records from stage table. Here we are doing SCD type 2 in stage number 4. Slowly changing dimension. Insert again in customer dimension from customer stage 1 SRC. So whatever data we are writing in stage 1 table, store this information in customer dimension temporary table. So since we are moving from one to another, we call it a slowly changing dimension. They keep the history also. Condition wise, they're same, only one condition I'm changing, which is inactive flag. Then once all the data is stored in temporary, we keep that information from temporary to main again. Copy phrase records from stage to temporary table. Okay, and I think for this, let's run all this query one by one. This time I will insert it. So update we already know. We'll insert one new result. So databases. We'll insert one row. So insert into dim customer values 13. And load date I will give now. Select a star from dim customer. So last entry we have there. Now for this result, will not run a script. Will run one by one. Okay. First, we need to run this script. We'll open this script. What this is doing? ETL job custom.sh. In this line number 46 is extracting your inserted data, but we have not yet created any job for inserted result. Okay, so we need to create one new job with that inserted data. So let's create the job first, and we'll delete this directory also, because in this directory already updated entries there. So copy this. So according to this script, we will first do these two things: minimize hdfs dfs -ls and paste this. So we don't need this directory. Anyway, that script is also doing the same thing. Here I'm doing that manually. rm r. This is deleted. Then job name scoop job -hyphen list. We can create a new job, or we can delete it. So if I create a new job, then again I need to update my parameter.txt. That's why I delete this. Scoop job, delete cust scoop job. And the new job is this scoop scoop job. Then create -hyphen create. I think it's, let me see that prior setup txt cat prior scoop job, create job name, and -hyphen import. Job name same cust scoop job -hyphen import, and then rest are same. Connect JDBC MySQL IP address database name username password table name dim customer target directory, and this target directory will be, so before target directory we will give incremental. This time it is append, incremental append. Then check column will have column name. Column name we can give this load date only, or we can give customer ID also, because for append we mostly give primary column, a table which has a primary key. So primary key column is customer ID. Check column customer ID and last value. So what was the last value? Last value was 12. Customer ID last value 12. Then target directory. And this target directory is the same which we have deleted. I'll take it from here. This is the directory. Paste here. Number of mapper, we give 1. All good. Run this. Job is created. Then execute this job using line number 46. Scoop job, EXEC scoop job. So scoop job hyphen EXEC and then cust scoop job. Enter. So I gave root as a password. It says this does not exist. Dim custom. Okay, spelling is wrong for customer. Customer. This is matching now. As we cannot edit, I need to delete this again. Good job. Delete. Enter. Again executing. So this will get that data and write in new directory. Okay, big data batch 1 or stage 1. This is having a name big data project batch 1. We'll wait. Once this is done, then I'll start running out of query as a hype query. Lower bound value is 12, upper bound value is 13. In between this, there is just one record. So based on condition, we can check also. One result retrieved, HDFS, DFS, hyphen ls. And by the way, no need to check manually. We already know one table in Hive is pointing to this directory. So you can open Hive cell and we can run query on there. Customer name stays table. Use FIU, so tables, select start from customer dim stage one. Okay, so new result is there. And now time to run this query in Hive cell. Exit and tell line number 46 this is extracted. Scoop job is succeeded also. Move on and check line number 63. So in the 63 line, we are running one Hive script. Hive con q. This is telling us dev environment. Then ETL data schema, that's a FIU, hyphen F, this is a file name. This is how we call any script in Hive. Hive script. This is the same HQL which we have open. And now we'll run this query. So exit from here. I'll copy this. This is the same script, okay? Now copy and paste. Because this is only active till your session is on. Once I leave the session as an exit from here, all the setting will go away and by default setting will come. So by default is a static partition. Copy. Paste. All three properties set. Then first query. I'm already inside FIU, so no need to use this. We'll run this query. Create temporary table from here. Okay. One change we'll do here. So create table customer name temp as second query was select start from customer name main limit 0. Okay, this is done. So tables, this is very slow because of it's running on a VM and this is running MapReduce job. Select. For fast execution, we can try this in GCP. Okay. Select star from customer domain and customer domain has all the result. Then TEMP. This doesn't have anything because it is only having a schema. Desk table name you can write or you can use so create table name customer dim TMP. This is having the same schema as main table. Then second query, I'll be running query one by one. And every stage will validate the output. So after this stage, we'll check the output of customer dimension temporary. Insert into TMP, or I'll do one thing. This copy. I will format here and I will copy the rest then. This will again run on MapReduce job. Okay, this is done. And total file in customer dimension temporary. So I think one only row is there because if we check our main table, there is only one condition which is passing it, this row, where we have n as a flag and not null. The rest everything is null, null, null. Select the start from customer dimension temp. Okay, that entry is there. Load expired record from main. So this was expired record. And this is a big query. This is required if your tables are in different databases. Okay, if they're in same database, we don't need them. Copy and paste. After this query, again we'll check customer dimension main table. Select the start from customer dimension main button. Okay, this is the same entry because this is only expired result. Step number 3. Okay, we'll run this query now. What this title says: copy active record from main to temp table. So there are total 6 active records in main table. This is a time taking query because we are doing many operations here. So 3 to 4 minutes this will take. Select start from customer dimension temp. So this has now active records. This result was already there, and this is all active records. Rest all you can see why. Now why we are keeping in customer dimension main table, that will be clear in fifth stage. After this, copy only updated records from a stage table to temporary table. This is only for updated result. So I think this query will only bring one result again. select this from customer dimension tab. So this result is already there. If new result is coming and updated but not available in customer customer dimension temp table, then they will store it. Since all is present already, they compared and leave. Uh, by the way, from here you can see how many rows they're writing. Total number of rows is 8. Previous data deleted, new data is stored. And last query is this one, customer dimension main. After this, we'll run replace the content of main table in transactional manner. So whatever data is stored in customer dimension TEMP, this will now go to main table along with the newly inserted data. So you can try this fifth and the last option, and inserted data you will see in your main table. Now, a few things I'll share with you. Project synopsis. What is the flow? So quickly, we have a few minutes, we can see that. Main question which will come from here will be this total flow of your deployment, how many stages you have. Then if you are working with this project, what is the business requirement, how many work stream we have. I have given example of financial. If you want to use the same financial, you can use this 5 work stream like transactions, monitoring, fraud data, analytics, fraud detection, which is ideally coming in the same category. Then emerging market, how many countries are doing well in terms of banking, underdeveloped country. Then anti-bribery and corruption, 4 to 5 cases we can use. This is your whole flow. HDFS. Surrogate key we did not perform here in this stage. So you can skip the surrogate key thing. It was required in previous version of Hive when there was no encryption level available, but currently we have encryption available in Hive itself. That's why we don't need surrogate key. From HDFS, you can directly connect with changing data capture, slowly changing, publish spaces, Hive face, and then we run a query using Elasticsearch or Solar from this business user. So here you will be 2 more services. You can use Elasticsearch for query. Then Hue is a front end. Using Hue also we can run a query. Currently we're using terminal. Yeah. Then after Hue, stuck. Okay. After Hue, total overview. That the same thing is written here in English. Like after first stage, what we're doing. Here we'll discuss about the uh, tools or data pipeline, like how many tools we are using from development environment to SIT like Jenkins, GitHub, Airflow, These are tools of Apache. Some are from Amazon, some are from Google. So whichever platform we are using, we can use that tool. I'll write the data pipeline. I will share that with you. After that, Elasticsearch. This is how visualization will look like. This is a sample code. If I process anything, any data in a scalding, we don't need a scalding in our stage, so we can skip this part. OrientDB also is not required. This is for data science and high-level analytics. This is a question. In Scoop or in Hive, what challenges you faced? What was the partition, and how did you resolve those challenges? So every stages, we have total 6 stages. Every stages will prepare 2 to 3 challenges. Then if any data issue is coming in your production site, then how you're recovering that from production to DR site, which is a disaster recovery sites. So in documentation, I'll share this. The whole concept of this project is historical data analysis, grabbing data from existing RDBMS, skipping in HDFS, and writing that data in Hive using CDC SCD type 2. We can add Spark and Scala also if you want to use any transformation, but that part will check on real-time data analysis. We'll not start that tomorrow. You can test this today. You can read everything, whatever session we have covered in this last 3 days. If any question is coming, we can have session tomorrow. Write me down in mail that you want to have this discussion again. If there is no question from starting to ending, then we can start next project on Monday or Tuesday, whenever we are flexible. But let's complete this first. You try everything by your end, then Spark and Kafka will start.